Hello everyone, I'm Paul and today we're solving problem 3318, find a sum of all k-long subarrays 1. Here it says this is an easy one, but this is at least a complex easy. So let's start. We are given an integer array nums, an integer k, and an integer x. So let's say that we are given this input. And we need to solve subproblems of size k here. Meaning we need to take subarrays of size k. And in case you know what a subarray is, it's a contiguous selection of elements. So for example, this is a subarray, this is a subarray, this is a subarray, but we can't form a subarray with these two elements because these are not adjacent, okay? And for each subproblem, we need to get the sum of the x most frequent elements. In this case, x is 2. And the two most frequent elements in this subarray are 1 and 2. So we do 1 plus 1 plus 2 plus 2. And this is 6, so we add to the result 6. Now we move to the next subproblem and do the same. Here we have number 2 3 times, number 1 1 time, number 3 1 time, and number 4 1 time. And we need to take the two most frequent elements here. The most frequent element is 2, and here every element has the same number of occurrences. So in this case, we keep the bigger value. In this case, the bigger key, meaning number 4. So we do 2 plus 2 plus 2 plus 4. And this is 10, so we put 10 in the result. And this is the last subarray of size 6, so we do the same. Here we have number 2 3 times, number 3 2 times, and number 4 1 time. And the two most frequent elements are these two, so we take 2 and 3. So we do 2 plus 2 plus 3 plus 2 plus 3. And this is 12. So for this input, we return this. And now the question is, how can we solve this? And this might seem overwhelming because there's a lot going on here. So we'll focus on only one subproblem. We'll take these 6 elements. So we need to find the two most frequent elements in this subarray. And in case you didn't notice, we can use a frequency map. And in case you don't know what a frequency map is, here we store frequencies for unique elements in this subarray. And how can we build this? Well, we iterate every element. We start from this one, so we add number 1, and this is the first time we see this number, so the count is 1. Next we are here, so now we add 1 to this number, this is now 2. Next we are here, so we put 2 with a count of 1. Here we have another 2, so we add 1 here, this is 2. Here we have a 3, so we add 3 with a count of 1. Finally we have a 4, so we add 4 with a count of 1. And from this we need to find the two most frequent elements, so we can put all of this into an array. And now we can sort this, so we can take the last x element, in this case 2. Now remember, if we have a tie, we need to keep the largest key. So actually we need to sort this first by index 0 and next by index 1. So we are sorting these 2 times in total, okay? So this would be the sorted array. And now we can take the last x element, meaning the last 2 elements, and the result for this subproblem will be 1 times its frequency 2 plus 2 times its frequency 2, and this is 6. So we add to the result 6. Let's do one more just to make this clear. First we build the frequency map, so we get this. And now we need to get the two most frequent elements here, so we build an array from this. And now we sort this first by index 0, then by index 1. So we get this after sorting, and now we need to take the last 2 elements, meaning these 2. This is the most frequent element. And here we have a triple tie. But given that we did a double sorting, we know that this element has the largest key, which is exactly what we want, okay? So we take the last 2 elements and we do 4 times 1 plus 2 times 3, okay? Key times frequency every time. And this is 10, so we add 10 to the result. Next, we update the I-pointer. We need to solve this subproblem, so we repeat the exact same process and add the result for the subproblem, meaning 12. So finally, we return this array. So with this in mind, let's go with the code and hopefully you will get the idea. First, we say n is the length of nums. Result is an empty array. And for I in range from k-1 to n, here we are iterating subproblems, meaning subarrays. The I-pointer is the rightmost element in each subarray. And here we do k-1 because we are working with indices. We need to subtract 1 from k. Every time we have a map, this is a default dictionary with a default value of 0 for every key. That's why here we use the word int. And for j in range from I minus k-1, remember the -1 is very important, to I plus 1 because I is included, we build the frequency map. So we say map at nums j plus equal 1. So now with this, we have a frequency map of the current subproblem. And now we can get the sum of the x most frequent elements here. So remember the approach. The result right now is 0. We will call this current. First, we need to build an array from the elements in the map. So here we can say map.items and we transform this into a list. Why? Well, because we need to sort this and we need to sort this 2 times. Remember the approach. And here we can say array.sort and this sorts the array by index 0 by default. So we can leave this as it is. And now we need to sort this again by index 1. So array.sort and key is lambda x x1. Now we can say for j in range x, remember we need to find the x most frequent elements. We can pop the last element every time, array.pop. And this will give us 2 values, key and value. So we can add to current key times value. Now, it might be the case that the amount of elements in the array is smaller than x. And the problem says that in this case, we need to add every element in the subproblem. So if we are out of elements in the array, here we can just break the loop. So if not array, break. After all of this, for every subproblem, we add to the result current. And finally, we can return result. So this is the entire code. Now let's submit this and see if it works. As you can see, this works and it's very efficient. Here time complexity will be big O of n times k plus k log k because of sorting plus x. And we can reduce this to big O of n times k log k. And space complexity will be big O of k. The result has a size of k. This map has a size of k every time. So space is overall big O of k. And sorting requires big O of k also. So This is it for this problem. If you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.